Hi there, folks. Today we're looking at completing the square, really solving by completing the square. And if you recall, we've talked about perfect square trinomials. This was the idea that sometimes trinomials factor into a perfect square, all right? So perfect square trinomials are trinomials that factor into the same binomial twice. So in other words, a binomial squared. All right, so these are kind of the key to doing completing the square and solving by completing the square. Essentially, what we're going to be doing is we're going to be creating perfect square trinomials. And the idea behind this is if we can create a perfect square trinomial, then we have something squared, and that is something we know how to solve. If I have something squared equals something else, I know I can solve using things like the square root, all right? And so the idea of completing the square is solving using the square root, all right? But we're creating a situation where we can use a square root, all right? And that's where completing the square comes in. So we're going to solve by completing the square. That just means we're going to solve using square roots, but we have to create something that we can take the square root of first, okay? So perfect square trinomials, here's some examples of those. X squared minus 4x plus 4 is a perfect square trinomial because it factors into x minus 2 times x minus 2, which is x minus 2 squared. It factors into a perfect square. It factors into something that I can take the square root of. X squared plus 6x plus 9 is also a perfect square trinomial because it factors into x plus 3 squared. It factors into a perfect square. It factors into something that I can take the square root of, okay? These are perfect square trinomials. And if I have a perfect square trinomial and I can factor it into something squared, now I have the opportunity to solve using the square root. That's where we're heading with this, okay? So first of all, we need to figure out, all right, how do we create a perfect square trinomial, all right? And so the act of completing the square is the act of creating that perfect square trinomial, all right? And all we have to do this is choose the right C value, choose the right constant term, choose the right number at the end of this thing, okay? Regardless of what B value I have, regardless of what's in front of the X, I can create a perfect square trinomial by simply picking the right value for the constant term, for the number at the end of this thing, all right? And here's how we do this. We do B divided by 2 and square it. That's it. We take that middle number, we divide it by 2 and square it. We take the coefficient of X, we divide it by 2 and square it. Okay, and there's one little stipulation that we have to be really careful of here. We can only do this, and this only works when the A value is 1, when the coefficient for X squared is a 1. All right, if I have anything other than a 1 in front of the X squared, I can't complete the square until I turn that into a 1. All right, for example, if I look at something like this guy, if I had x squared plus 10x plus c, all right, and I'm going to replace the c. I'm going to pick a new value for that number at the end, all right, that's going to create a perfect square trinomial. All I do is b divided by 2 and square it. And so in this case, the b is a 10. So if I did 10 divided by 2 and then squared it, well, 10 divided by 2 is a 5. 5 squared is a 25. So in other words, if I were to change this to x squared plus 10x plus 25, that is now a perfect square trinomial. X squared plus 10x plus 25 is a perfect square trinomial because it factors, if I were to build a bridge and factor this thing, this factors into x plus 5 squared, okay? And I get that just by simply picking the right C value, okay? So again, this is the value I need to choose so that I can get this situation, all right? If I look at the next one, same kind of thing. If I take that negative 18, that b value, divide it by 2 and square it. Negative 18 divided by 2 is a negative 9. Negative 9 squared is a positive 81. So that's x squared minus 18x plus 81. That is now a perfect square trinomial because it will factor into a binomial squared. If I were to build a bridge here, this would factor into an x minus 9 squared, okay? But that's what we're trying to create. We're trying to create a perfect square trinomial so that when I factor it, I can get something squared. This is the value I need to choose to do that, okay? So now let's talk about solving by completing the square. So solving by completing the square, I'll have this quadratic equal to something. What I want to do is I want to pick a C value that creates a perfect square trinomial. So step one is I'm going to create space. I say create space, and I literally will create space. I'm going to create a blank space in my equation where I'm going to pick the C value that I want. I'm going to pick the number that I want to make this thing a perfect square trinomial. I'm going to do what I did in the previous examples. So in order to do that, to create space, I basically just move the term that I have out of the way, all right? you're going to start with some constant value that you don't want. It's not the c value that makes the perfect square trinomial. So what you do is you move that guy. You bring it over to the other side of the equation. You get rid of it. You get it out of the way so that you have a blank space so that you're free to pick the c value that makes the most sense. So I create space by moving the constant term that's there. I get it out of the way. And then step 2, I pick the constant term that I want. I complete the square by doing b divided by 2 squared. I pick the constant value that gives me a perfect square trinomial. And keep in mind that when I do that, when I put that, plus 25 or plus 16 or plus 9 there, all right, I'm putting a plus value on that side of the equation, which means I have to do the same thing to the other side of the equation, okay? Then I'm going to factor the perfect square trinomial. See, I've created a perfect square trinomial. I factor that perfect square trinomial. I factor it into that format of something squared equals something else. And then I can solve by taking the square root, all right? And so here's what this amounts to, all right? I start off with a trinomial that's not perfect. I move the constant term out of the way. I pick a value that gives me a perfect square trinomial. That allows me to get something squared when I factor it. And that leads me to being able to solve using the square root, which we already know how to do, okay? And so this looks a little bit complicated, but it's actually pretty simple when you really start to get into it, especially if it's the kind of examples where completing the square is easy, and hopefully you're still thinking about that, okay? For example, if I look at this guy, okay? If I wanted to solve this by completing the square, all right, if I looked at the b value is a 2. If I did b divided by 2 squared, that's a 1, all right? That's the value that's going to create a perfect square trinomial. But I don't have a 1, I have a minus 8 there, okay? So here's how this works. I just say, you know what? I'm going to pick a c value. So the first thing I have to do is I have to get rid of the c value that's there. So I create space. I'm going to add this 8 over to the other side. I'm just getting it out of the way. And when I say create space, I am literally going to create a blank space. I put a blank space in my problem, okay? So I say x squared plus 2x plus something is going to equal this 8, all right? And now I complete the square. I fill in the blank, b divided by 2 and square it. And you could take that off to the side if you need to. 2 divided by 2 is a 1. 1 squared is a 1. So I'm going to put a plus 1 in this blank. That creates a perfect square trinomial. See, now I have a perfect square trinomial. But keep in mind, I just put a plus 1 on the left side of this equation. I better put a plus 1 on the other side, okay? Because again, that's part of solving equations. I have to do the same thing to each side. Now let's factor this perfect square trinomial. Let's prove that I have a perfect square trinomial. This guy, build a bridge. 2 numbers that multiply to a 1 but add to a 2. Well, that gives me a plus 1 and a plus 1. So this factors into x plus 1 squared. Okay? And that equals a 9. And if you need to take that off to the side, if you need to build a bridge here and say, okay, that's a 1. So 2 numbers that multiply to 1 but add to 2 is a 1 and a 1. And now this factors into x plus 1 using my shortcut and x plus 1, which I then rewrite as x plus 1 squared. Okay? Again, we're kind of abbreviating this. We're taking some liberties here in terms of doing this a little bit faster, a little bit quicker, and taking some shortcuts. But all I'm doing is creating a perfect square trinomial and then factoring that trinomial. And see, now we're in a situation like we had when we were solving using the square root. I have something squared equals 9. And remember, I just worked backwards to order of operations. I undo the exponent by taking the square root of each side. When you take the square root of each side, don't forget to do plus or minus this value, all right? Because remember, technically, when we take the square root of x squared, it's the absolute value of x. So then we have to split it up. But we just remember, hey, when you take the square root, you got to do plus or minus that value. Now I can undo what was in the parentheses by subtracting the 1 from each side. And just like before, here I've got x equals, that's a negative 1 plus or minus 3. Well, I should actually simplify those. Ready? If I continue to simplify, negative 1 minus 3 is a negative 4. Negative 1 plus 3 is a positive 2. And that's it. All right? And the fact of the matter is, this particular example, I got a nice, neat, beautiful answer here of negative 4 and positive 2. You won't typically get answers like this when you solve by completing the square. If you get an answer like this, it means that you could have solved this by factoring. Look at the original problem. I could have built a bridge right here. 2 numbers that multiply to a negative 8 but add to a positive 2 are a positive 4 and a negative 2. Then I could factor that in x plus 4 and x minus 2 and then set each of those equal to 0. Okay? I only start with an example like this to show you how simple this can be. The reason we want to use this is for examples where we can't solve by factoring. And so if I look at the next example here, Go ahead, try building a bridge. Two numbers that multiply to a 5 but add to a negative 10. It's not going to happen. There are no two numbers that multiply to a 5 but add to a negative 10. So I can't solve by factoring, but I can still solve by completing the square. And so here we go. I'm going to subtract the 5 from each side. I create space. And again, I do that literally. I literally create a blank space. Now let's create a perfect square trinomial. B divided by 2 and square it. Negative 10 divided by 2 is a negative 5. Negative 5 squared is a 25. So I'm going to put a plus 25 here. So now I've created a perfect square trinomial, but I did that by putting a plus 25 on the left. I better put a plus 25 on the right. Okay? And now I factor this thing. So factor your perfect square trinomial. This guy factors into an x minus 5 squared. Over here, I add these up, and that's a 20. And now I'm in a situation where I'm going to solve using the square root. So I take the square root of each side. Again, I'm undoing the exponent. Don't forget your plus or minus. And I also want to simplify this. Remember, 20 is 4 times 5. The square root of 4 is a 2. The 5 is still trapped. And yes, I'm encouraging you to start doing those in your head. If you need to take that off to the side and simplify it, that's fine. You know, bring it off over here and say, hey, 4 times 5. Then the square root of this guy is a 2. The 5 is still trapped. Okay? And now I undo what was in the parentheses down here, so I'm going to add the 5 to each side. And this one, these are not like radical terms, so I can't continue simplifying. I just leave it as 5 plus or minus 2 root 5. That's how we leave it in terms of the exact answer. We leave it in radical form. If we were doing some kind of word problem, and we'll do some of these down the road, but you might have to plug this in as a decimal approximation. That's okay. But you do two things. You would do 5 plus 2 root 5, and then separately you would do 5 minus 2 root 5. Okay? And so if it asks you to round to the nearest whatever, all right, instead of leaving your answer like this, you're actually going to plug each of those into the calculator. Okay? But this was one that would have been impossible to solve by factoring, and that's why completing the square is important, okay? If I look at this guy, again, same kind of thing. I'm going to create space. And hopefully right away you see the issue I'm about to have. It's not going to be pretty. B divided by 2 and square it. 3 divided by 2 is like 3 over 2. And then 3 over 2 squared is actually a 9/4. And whatever I do one side, I have to do to the other side. And so right away, this thing is awful because look at the fractions I have to deal with. And now I have to worry about factoring this thing, which if you don't know the shortcut is real pain. I do know the shortcut, so it's just 3/2 squared. Over here, I have to get common denominators, and 1 is like 4 over 4. So when I add those together, that's 13 over 4. Okay? And now I can solve using the square root. I take the square root of each side. So here I get x plus 3/2 equals, well, I got to remember my plus or minus. I also have to do each of these individually. The square root of 13 is the square root of 13 over. The square root of 4 is actually a 2. And now I can subtract this 3/2 from each side. And again, this doesn't look pretty. It looks gross. All these fractions floating around. Nobody likes this. And see, I kind of flew through that example and didn't offer as much explanation as I normally would here. That's because when you look at this, it doesn't look nice. And the fact of the matter is, for a question like this one, I would not use completing the square to solve. We're going to have another method that we use when completing the square isn't a great option. The real question becomes, what makes this not such a good option? How do I identify when completing the square is a good option to use for solving? And as you looked at these guys, what made these easy compared to the question I just did? And the answer all boils down to the b value. If you look at this first example right here, the b value is a 2. Here the b value is a 10 or negative 10. Here it's a 4. Here it's an 8. And then here it's a 3. And hopefully the realization is, well, When the b value is an even value, when the b value is divisible by 2, completing the square is not so tough. But when the b value is odd, completing the square is a real pain, okay, because of the fractions involved. That's what I want you to see here, all right? The other thing I want you to notice, like on this next example, if I look at this guy, I've already created a little space, but the other issue is I'm not allowed to complete the square on this one because the a value is not a 1. See here, I'd have to divide this by 2 first before I can create that space. See, now it's x squared minus 5 halves x with a little space equals 3. And, if you don't follow along with this, and that's okay, I'm going to run through it quickly, but I would never expect you and never want you to solve a question like this by completing the square. So let's make that clear. And so I want you to remember these keys, all right? Scroll back up to these. If you could do these examples, if you felt good about these examples, then you are in great shape, because completing the square is easy when the a value is 1 and the b value is even, okay? Completing the square is a good option when the a value is 1 and the b value is even, because then everything works out nicely. We move the constant term, b divided by 2 and square it to create our perfect square trinomial. Make sure you add that to each side. Factor, solve using the square root, okay? And everything works out nice when a is 1 and b is even, okay?